Okay, so here's the last one, and again, I thought I had it working, but I didn't. So, my apologies. So this is number 93. So I've started with this problem right here. So for these, we're going to rationalize the denominator. And in order to do that, when you've got two terms in the denominator like this, you're going to multiply by what's called the conjugate. These terms under the radicals stay the same, but if this is a plus, then you make this a minus, and vice versa. If that was a minus, you'd make this a plus. As you can see by problem 78, which I assigned, if you multiply by terms that have the same terms under the radicals here, but one's a plus and one's a minus, what you should end up with the end is a whole number. And that's the whole point of this, because if you remember, we can't leave a radical in the denominator. So using the conjugates like this allows us to get the radicals out of the denominator and leaves us with a nice whole number when we finish. So I'm going to multiply my starting term here by the square root of 5 minus the square root of 3 on bottom, and whatever I do on bottom, I have to do on top. So that leads us to this part. We've got the square root of 3 times the square root of 5 minus the square root of 3 on top, and then our terms on bottom. So I'm going to distribute my square root of 3 through on top here, which gives me my square root of 3 times square root of 5, this term times this term, minus the square root of 3 times the square root of 3. Since this is positive, this one's negative. The negative wins, so we're left with this. Now if we move down to our denominator, I'm going to multiply this square root of 5 times everything in my second set. So I've got the square root of 5 times the square root of 5. That's this term here. The square root of 5 times the square root of 3. And again, that's positive, that's negative. The negative wins, so that's that term there. So now I've multiplied this term by everything in the second set. I'm going to move to my square root of 3 here. So the positive square root of 3 times a positive square root of 5 gives us plus the square root of 3 times the square root of 5. And then positive square root of 3 times negative square root of 3, negative wins. So I've got that term there. Okay? Alright, now I can just start simplifying things down. Again, you've got two radicals multiplied together. If it's the same kind of radical, meaning if they're both square roots, both cubed roots, you can combine those terms underneath a single radical. So this now becomes the square root of 3 times 5, or the square root of 15, minus the square root of 3 times 3, or the square root of 9. And then on bottom, I've got the square root of 5 times 5, which would give me 25. And I kind of scribbled through and crossed everything out here. So hopefully you can see behind all that what that says. So I've got minus the square root of 5 times 3, which would have given us the square root of 15. And that is a negative sign, I promise. It's kind of hard to tell. And then plus the square root of 3 times the square root of 5, or plus the square root of 15, and then our last term here, minus the square root of 9. So on top, we've got the square root of 15, which we can't reduce down any further because there is no perfect square that divides evenly into 15, so we're going to be leaving that alone. But the square root of 9 simplifies down rather nicely to just 3. So I've got the square root of 15 minus 3 on top. Now down on the bottom, the square root of 25 simplifies down to just 5. And as I've scribbled out rather thoroughly here, this term was negative, this term was positive, and they were both square roots of 15. They cancel each other out, which is why I've crossed them out here. So they drop out completely, and we're left with just minus the square root of 9, which again is a nice whole number. It's just 3. So, again, this is illustrating why we rationalize the denominator using the conjugate, because now we've just got 5 minus 3 down in the denominator. So my final answer is going to thus be the square root of 15 minus 3 all over 2.